Hello friends, welcome to another video in filter realization. In this video we'll talk about the realization of IIR filter using lattice structure. A typical question would look something like this, where the transfer function is an all poles function where we have the numerator is equivalent to 1 and we have numerous poles here, and you'll be asked to find the lattice coefficients and you'll be asked to draw the lattice structure of an all-pole IIR filter. Now, in such questions, the first thing that you need to know is the structure of an IIR filter. The structure of an IIR filter is something like this, and you need to commit this to your memory, that you have this input and you have these delay blocks, and these coefficients are arranged in the reverse directions, and the coefficients are k1, and in the upward direction it is minus k1, then you have k2, in the upward direction it is minus k2, and so on and so forth. So from this transfer function we need to find out these coefficients and fill up here, and the number of delay blocks that you need to put up here is the highest power. So we have the highest power as 3, so we put up 3 delay blocks and move backwards in terms of the direction of the arrows. Alright, so this structure needs to be known for an IIR filter. Then the only thing left out is to find out these lattice coefficients and fill up here. So let's see how you find out these lattice coefficients. You need to remember this formula, that a of m minus 1 of z is equivalent to a of mz minus km b of mz upon 1 minus km square, and bmz is z minus m, am z minus 1. So these two formulas are needed to be remembered to find coefficients. Now you must be wondering what this a of m minus 1 and am's and bm's are. So it is pretty simple. From the question you'll find a3 of z, because the highest power is 3, so you'll find a3 of z, which is nothing but this equation in the denominator. So our a of 3 will be directly found from the question, which is this. Right, and similarly you can find b of 3 from here. You can multiply it with z raised to power minus 3 and a3 z inverse. So all the powers of z will be made positive. So if you were to find b3 of z, that would have been simply z raised to power minus 3 and 1 plus 0.9. This becomes z, this becomes z square, and this becomes z raised to power 3. And when you multiply this, so this becomes minus z3 plus 0.9 z square minus 0.8 z minus 1. This will be minus 2 and this will be 0.5. And to rearrange in the ascending orders of the powers, you get 0.5 minus 0.8 z inverse plus 0.9 z power minus 2 and plus z raised to power minus 3. And an interesting thing that you can remember is that the coefficients of b3 are reversed from a3. So this 1 goes here at the highest power, this 0.9 goes here, this 0.8 goes here, and the highest power coefficient goes to the 0th power coefficient. So if you do not wish to calculate b3, you can simply reverse it also, but take care of the negative signs because the coefficient also includes the sign. So but anyhow, you can calculate b3 also, and Now comes the K3, the coefficient K3. It is hidden in A3. The coefficient K3 is hidden in this equation, and it is nothing but the coefficient of the highest negative power, which is 0.5. So K3 will be 0.5. So this is known from this equation. You did not have to calculate A3, you got it from the equation, and from the equation you simply deduced that this 0.5 is K3. So this part is done. So this is 0.5, this is minus 0.5. Now you're left with finding K2 and K1. To find K2 and K1 you need to find A2 and A1s. So if you substitute M as 3, so you'll get A2 here, and you would need A3 and B3 here to calculate A2. Let's see how we do that. From h of z we can find a of m z directly. In this case we found a of 3z, and the coefficient of maximum m z minus 1 is K3. And now we can find A2. We just found B3 in the previous slide, so substituting that, B3 is this, as we found in the previous slide. Substituting this in this equation, we get A2 as, this is AM, this is Km into Bm upon 1 minus Km square. My A2 becomes this, and the coefficient of the maximum power is K2. Easy. And from A2 we can find B2. With the help of A2 and B2, now we can find A1. So when we found A1, the coefficient of the maximum Z power is K1. And now once K1, K2 and K3 are known, we simply need to substitute the values of K1, K2 and K3 in the lattice structure for IIR filter, and we get our answer. So we substitute the values here for K1, K2. Please understand the value of K1 going downwards is as it is, and the value of this arrow is minus K1. Well, that was it for today's tutorial. I hope you liked it. If you did, give it a thumbs up. Consider subscribing. I'll see you around. Bye.